Please join me in welcoming Dr. Bahman-Zadeh, a talented young researcher whose passion lies in the realm of concrete technology and durability. Dr. Bahman-Zadeh's focus on LC3 cement and alkali activated materials represents the cutting edge of sustainable construction practices. With her innovative approach and dedication to advancing the field, Dr. Bahman-Zadeh promises to make significant contributions to the future of concrete technology. We are privileged to have her expertise and insights shared with us today. So please put your hands together for Dr. Bahman-Zadeh.
Hello, everyone. Firstly, I appreciate Professor Khalu and other organizing committee for these two memorable days. Let's start with one of the important issues in the recent years, carbon neutralization. As you know, to avoid worsening the damage caused to the climate, we need to drop the amount of CO2 released to the air and reach to carbon net zero around 2050. Achieving carbon neutralization by 2050 makes our future more sustainable, but what does it mean? This means that we stop adding more CO2 to the atmosphere than we can remove it. In the construction, what is the new paradigm by considering this policy? What should we do to reach this policy? Many documents have been established recently. Here you can see two of these documents that can be a good guide and roadmap for our future. According to these documents, the growth in cement use have been significantly increased comparing to population and other industry. And also, the cement materials make up to 30 to 50% of everything we produce. This is mainly because of civilization, development in infrastructure, and also other needs of a new world. According to Professor Planck stated yesterday, carbon net neutralization strategies in cement industry can be divided into two strategies. First, carbon capture by removing CO2 from the air, and second, reduction in clinker factor, which the second one is more suitable for our work. As you can be observing this diagram, until 2020, the clinker to cement ratio was increased because of the development happened in the countries. After that, with considering the net zero scenario, we have to decrease this clinker to cement ratio and achieving to 0.65, and at the target point means 2050, this ratio should be around 0.30 to 0.4. Clinker substitution stated as a successful strategy, and it's with each 1% drop in the clinker factor, we can have 8 to 9 kilograms CO2 reduction per production of cement ton. One of the best solutions for achieving the foreseeable future is the using of SCMs. But there is an important issue that related to the availability of these materials. As you can see, the in usage of the SCMs were increasing in the recent years, but the availability of SCMs, as you can see here, is cannot answer the need for the achieving the target point, means 0.3 to 0.4 cement clinker factor. One of the best solution that can be answered to this question is the using of calcined clay. Calcined clay are widespread around the world, and you can see here in the sharper color, they are very available in the around the world. And also in many regions, suitable clays stockpiled as a waste in the deposits. Another material that can be used is limestone, which fortunately we have huge resources of this material in our country. Okay, to answer carbon net zero, there is no magic needed. Reduction, clinker factor with suitable SCM, which is widespread the world. Even more interesting is the use of calcined clay combined with limestone, which we can see the LC3 project here. LC3 project started at 2013 with these ratios of materials. In LC3 system, 3 different reaction happened. First, calcined clay with, which is the normal pozzolanic material reactions, calcined clay with calcium hydroxide. The second reaction is between limestone and calcium carbonate phase with C3A. And another reaction that is here we see is the synergic effect between the aluminate phase of the calcined clay and calcium carbonate, which results in the precipitation of carboaluminate phases, monocarboaluminate, hemicarboaluminate precipitation. And this synergic reaction allows high level of substitution in LC3 system. You can see here that in LC3, until 2000 year, we have just standards with clinker replacement of 30%, around 20 to 30%. But in 2021, the clinker factor introduced as 50 to 65%. One of the benefits of this LC3 system is that we can use, we don't need to use very pure clay. With low grade or moderate grade of clay, we can reach to LC3 with proper properties and good permeability properties. But what we do in Iran, we start researching about the localization of this technology after passing doctoral school at EPFL in 2018, which was before the EN standard in 2021. So we decided to produce LC365. We identified the rich supplies around Iran and we gather samples. Here you can see our process to produce a laboratory scale of limestone calcined clay. First we crush and then analyze the raw clays, and after that we calcine the clays at laboratory furnace at 800 degrees C. After we grind the clays, and finally we measure the pozzolanic activity. We have 7 different samples of raw clays. 3 of them was rejected because of duration of grinding time, and also pozzolanic activity was not very proper. We select 4 different clays with different kaolin content in their structures. As you can see here in the picture, the different content of iron oxide result in different color in the clays. And the increasing kaolin content results in increase in pozzolanic activity. As I said, we have good resources of limestone. Let's open a parenthesis. After our study in the field of LC3, we suggest the estimated equation for measuring the kaolin content in raw clays. It just not need to be done, do a very complicated test to reach kaolin content like TG. We just by XRF analysis, which is used for measuring the chemical composition, we can achieve to the phase assemblage, which cannot demonstrate the mineralogy. We can measure the kaolin content. In this paper, you can have this equation. Here is our team experimental program. Me and Dr. Farnaz have planned to analyze the properties of domestic LC3 with considering the effect of fineness, sulfate adjustment, kaolin content in the structures, and we carried out many tests with our colleagues, which were MS students, some of them were PhD students. The durability was evaluated by considering sulfate attack, alkali-silica reaction, carbonation, acid attack, and corrosion. We prepare paste, mortar, and concrete samples and consider 9 different mixture proportion. In these 9, we have a control mixture, a 4 binary mixture, and 4 LC3 mixtures. For here today, I focus on the program on evaluating chloride-induced corrosion. We evaluate the permeability, chloride binding capacity, and measure the profile and analyze the corrosion in the samples. For permeability test method, we conduct MIP and paste samples and what's different water absorption test on the mortar and concrete samples, and also electrical resistivity. Among the tests conducted on the mortar and concrete, we see that the water absorption test based on BS cannot cannot accurately estimate the permeability of LC3 because of the preparation on under 100 degrees C. As you can see here in thermodynamic modeling of the LC3, ettringite phases are stable in LC3, which decompose, which start to decompose after 60 degree. We see that the threshold pore entry radius in LC3 samples were smaller than control and increased and decreased by increasing in the kaolin content. The proper behavior of LC3 and binary cements can be seen. More significantly, more important result we achieved was about the binding capacity of LC3 system. In LC3 system and also binary system, by considering the alumina, high alumina phases in their structure, they have better chloride binding capacity, and you can see that the dependency on the alumina content increased by increasing in the solution, NaCl solution. We evaluate the chloride ion ingress in the mortar and concrete samples. We see that calcined clay containing samples have better performance than control mixtures in both binary and ternary. We also evaluate the chloride ingress in different exposure conditions. We consider 4 different exposure conditions according to the marine construction, marine structures. First was submerging. The second was drying and wetting in cycles, and the third one was drying and wetting combined with accelerated carbonation, and the fourth one, which I don't state here, was the pure carbonation. As you can see here, different behavior was obtained at different exposure condition. The shape of the profile changed, and it is not similar to normal because of the convection zone, and different changes in the cycles causing by drying and wetting. But you can see that the same trend was happened. Yeah, it means that at the interior point for LC3 and calcined clay containing binders, we have lower chloride concentration and better behavior. We also evaluate the corrosion in a semi-submerged sample. You can see here by a half-cell test. The time of chloride-induced corrosion was shorter in LC3 and calcined clay because of better permeability and also increased chloride binding capacity. But after the initiation, means after 350, the rate of corrosion increased in the samples because of lower alkalinity. And finally, I can introduce as LC3 as an environmental, economical, available, and durable approach for our future. Thank you.
Thank you so much for your presentation. We have time just for 1 or 2 questions. Please, Professor Plan. Take microphone.
Thank you for excellent presentation and many test results. I'm very impressed. And I'm also very happy that you're working on clinker substitution using calcined clay, or we call it activated clay. From your slides, I understood you have a preference for a raw clay which is high in kaolin. Is this correct?
No, we just focus on moderate and low-grade clay with 19 to 60% kaolinite in their structures.
Mm-hmm. Because in Germany we have studied this very extensively, clays with kaolin contents from 6 to 50%, and we clearly found the low kaolin clays much more preferable with respect to workability, water demand, and so on. The only thing is they react slower in the hydration at the beginning, so the early strength is lower, but we have powerful chemical admixtures where we can correct this. So it's not really a problem. And I saw you measure the reactivity of the calcined clay. Which test do you use? For the pozzolanic reactivity.
EM, I think, yes. ASTM, I think. Yes.
Is it the R3 test
Yes.
or?
I think we use ASTM. Maybe I can.
Because different tests produce different results, we saw. And there are some tests which are more reliable or realistic, I should say, and others less. Beautiful picture, by the way.
Sorry. We use ASTM standard for pozzolanic activity. I bring. Okay.
Anyway, we can discuss
Okay.
later.
What is
Thank you so much.
Okay.
Yeah.
We use strand-based ESTM. We prepared the sample. After 28 days, we measure the compressive strand. Yes, compressive strand. We don't use chemical. We try to use R3, which suggested by APFL, but we was not succeeded in this. We use ASTM, which based on compressive strand on the mortar.
Okay, thank you so much. You emphasized on, on Fe2O3 content of the kaolin. Is it important in your opinion?
It is not cause any change in the result. Only by architecture, the
color,
LC3 team said that some of them it has disadvantages from because people know the cement
terms of
should
the
be
activity.
gray.
No.
The activity no. But we can remove the color, but some by some considering some process. But in Iran, I think red color is good because of architectural issues.
Just one concern. In terms of thomazite sulfate attack, as we use...
Yes, but we don't publish it yet, and we just gathering the
Is it
result.
important in LC3 as well, more than other
Yes, it was in LC3 because of the... It was
So in
seen
some cases, we don't have to use LC3, yeah? In some cases where...
in some cases, yes.
Okay.
We published our paper, I think, after concluding the final result. We published the paper.
Okay, thank you so much. Yeah, upload again. So we finished the session, isn't it? Yeah? And we have to come back at 2:15 maybe. Yes, Dr. Halu? We come back at 2:50. Okay, 2:15.
Yes, it's just the lunch break for 60 minutes. Try to be back in the venue after 60 minutes and just have fun.